And as I said, we're going to discuss in more detail this when I go through a review of the unit. Your exam, by the way, is Wednesday. But the idea behind maximizing or minimizing something is that thing you want to maximize or minimize is a y value. In this particular question, you want to minimize the cost, but when you take a look at this equation, and I'm going to take the function notation and throw it in the bin because it really can confuse you. When you take a look at that equation, what I'm telling you is if you want to minimize the cost, then you have to think of cost as being y and the other variable as being x. The reason for that is because if the cost is y, and we know that the cost is equal to a quadratic function that opens upward, then the quadratic function will look like that. And this, we learned from pretty much day one of this unit, is a minimum value of y, but y is the cost. If you take a look at question, I think 14, it's the same kind of thing. A gymnast is on a trampoline. His height is measured in meters and it's given by the variable h. Well, you want to maximize the person's height. You want to find out what their maximum height is. So the thing you want to maximize is y. Why does that work? Because if h is y, and I believe it's t is x, and you take a look at this function that I'm highlighting, you can see that that function is a quadratic function. That function is a quadratic function. Since it has a leading coefficient of negative, in other words, it's a negative x squared term or negative t squared term, it will open down. Well, a quadratic function that opens down, we learned on day one, has a maximum value of y, and that's why we chose h as y, to find the maximum. So that's really important, I think, that you equate the thing you want to maximize to be y. The other thing, though, that I need to say is in question 13 and question 14, you're given the function. You have it. And as far as I'm concerned, there's two ways for you to proceed here. You could either complete the square of that or you could use your graphing calculator. But be aware you are expected to be able to do this algebraically on a written response. Algebraically does not mean do it on your calculator. It means complete the square. Now, where does that take us? 15 is like that. Gives you the equation. But when you get to 18, when you get to 19, when you get to any of those area problems, and I don't see one here, but there might be one earlier. When you get to any of those area problems, you have to come up with the function on your own. So all that being said, does anybody have any questions from any of the assigned practice from last week? Go ahead. 18. So this one. So a concert promoter is planning the ticket price for an upcoming concert. At the last concert, what was charged was $70 per ticket, and there were 2,000 tickets sold. I'm going to tell you right now that the written response on Wednesday, worth 25% of your exam, will be a word problem that's a max-min problem. Okay? And I will also tell you right now it will be a choice. You'll turn to the written response section. It will say, in this section, complete one of the following two problems. You need to know how to do this kind of problem algebraically. You need to know how to do an area type of problem algebraically. And although some of you may have been shown how to do, say, this type of problem 4 or 5 times, it doesn't mean that everybody knows how to do it. You might need to see it a 6th or a 7th time. Okay. So, at the last concert, when she charged $70 per seat, she sold 2,000 tickets. Of course, as the number of tickets, I'll do it this way, as the cost per ticket goes up, you would expect to sell fewer seats. And that's what's going to happen. In fact, we're told the specifics of that. The promoter has determined that every one decrease in ticket price, she's actually going the other way. Instead of increasing the ticket price and losing people, she's decreasing the ticket price and gaining people. So what we're going to do is let X equal the number of $1 increases. Now I want to be very careful here, because, Sasha, if this said for every $2 decrease, then we would have said X is the number of $2 decreases, okay? So it isn't that X is always the increase or decrease in ticket price. It's the number of, I call them bumps. It's the number of bumps in the ticket price or drops in the ticket price. So question A is what it really boils down to. What's the maximum revenue? What ticket price can give that revenue? How many ticket prices will you sell? Or how many tickets will you sell? And I would actually go so far, everybody, to say A and B are the question. The question on a written response would be, determine what should be charged per ticket, how many tickets you're going to sell, and what the maximum revenue will be. All three of those things. So we have to start by coming up with a formula for revenue. Revenue is the price per ticket multiplied by the number of tickets. This is how we determine how much money comes in. The word revenue means money coming in. It's not profit. It's just revenue. It's the incoming money. So what are they going to charge per ticket? Well, they were charging $70, and this is maybe one of the trickiest things, not to figure out what we put here, but to understand something at a deeper level. The revenue is a revenue for all situations. This isn't the revenue at $70. It isn't the revenue at $69 or $68 or $67. It's the revenue for any ticket price. So it was $70, but we are decreasing by $1 for every X. And the reason why I didn't just write minus X goes again back to this, that if this said $2 decrease, this would be a 2, and this would be a 2. It doesn't, so it isn't. But if it were, it would be. What about the number of tickets sold? Well, it says that when you lose $1 per ticket price, you sell 50 more tickets. So the number of tickets sold will be the original number, which is 2,000, plus 50x. Because for each X you gain $50. And now what we have to do here, everybody, let's assume this is a written response. Because, you know, if it weren't, let's do it on a calculator like it were a multiple choice. And then we'll talk about the written response. I don't need to simplify this before I put it in my calculator. In fact, if I am going to solve this on my calculator, I think simplifying it is a mistake, because as soon as I start to simplify it, I can make a mistake, can't I? A numerical mistake, an algebraic mistake. So I can just put in for y, in brackets 70 minus x, times in brackets 2,000, plus 50x. And now what I want to do is explore my window settings. So first of all, everybody, she is decreasing the ticket price. So could it be that she's decreasing the ticket price by $1? Yeah. Could she decrease it by $50? Maybe. I don't know. Why don't we go from 0 to 50? In our head, I'm just going, by the way, I'm going to go 0 to 40. I don't want to use 50 and maybe have you believe I'm using 50 because of this 50 that I've written on the board. I'm just going to go up to 40. And I didn't even need to enter that in. What I could have done, and I'm going to do this anyway, is go to my table setup, start at 0, and go up automatically by 1. So I'm going to see the effect on the revenue, which is Y, as X is 1 and 2 and 3 and 4 and 5, etc. when I go to my table. And I can see the revenue is going up, isn't it? This is her revenue. It's climbing, it's climbing, it's climbing. I don't know if some of you can tell, but I don't think it seems to be as climbing as fast right now as it was originally. And that tells me, it's about to turn around. So when I look at my Y values here, everybody, I can see that Y peaked somewhere around 151,250. Probably at that number. But that means I can go to my window setting rather, and go up to, what did I say, 151,200 about? So if I go up to 160,000, that should do it. 0 to 160,000. And I can actually start, I'm going to actually start at 0 for both of those. I don't want to start at 0 if I'm ever finding X-Intercepts, but for this is fine. So these are the window settings that I'm using. Let's see if my logic was sound. Yeah, it looks good. I'm not really seeing a great parabola though, am I? Yeah. Oh, thank you. Oh, look at that. Oh, it's better. It's still, there's a lot of wasted space below. We could clip off that bottom space and then see more of a curve, but that will be good enough. Thank you for that, Lucas. What am I looking for? Max, enter, put my cursor to the left of that. I've got a little bit of an awkward situation here where I can't really see the curve because my equation is over top of it, but I'm pretty sure that's on top or to the left. And then move your cursor to the right. Now we're still not going to be done here. I want to talk about the answer and then I want to talk about the algebra behind it. So this is what we are getting. What does that mean? I'm going to redo this in exaggerated form. That this is your revenue. So this is your maximum revenue. This is what I'm going to start calling optimal. Optimal is ideal. This is your ideal value for X. As a person who wants to make money, that's X. So we can see that that is at 15. The optimal X is $15 or 15. The maximum revenue is $151,250. So what are we asked to find? You were asked to find here, Sasha, the maximum revenue. I have it on the board already. You were asked to find the ticket price. Now don't forget that this X is not the ticket price. The ticket price is $70 minus 1 times X. That's the ticket price. So that gives me, I think, 55 clams. I guess if you wanted to find, this is per ticket, I guess if you wanted to find the number of tickets, you could take the 151,250 and divide by that much. Or the number of tickets would be, was it 2,000 plus 50 times X? I said 2,750. So 2,750 tickets sold. Hopefully if you multiply those two numbers together, you get 151,250. Because if you didn't, then I've done something wrong. You do? Thank you, Shannon. But what if it's a written response? You do all that and it's a written response, I'll give you 1 mark, maybe 1.5 out of 5 for coming up with the equation. So if it's a written response, this is what you would have to do. You have to do this. And again, be very careful, because it could be that you're told the ticket price is going up or down. It depends on the situation. The first step here algebraically is to simplify this, because in order for you to answer this question, you need to complete the square of this. That's what you have to come up with. You have to complete the square of this to get an answer, to see what the maximum revenue is, to see what the optimal X is. But you can't complete the square until you have a standard form. You've got to get a standard form before you complete the square. So we have to FOIL this out, in other words. I'm going to ask you to follow along on your calculator to double check things. When I take 70 times 2,000, I believe I get 140,000. And then my outer will be 70 times 50x, and I believe what I get there is 3,500x. Excellent. My inner is negative x times 2,000, which is negative 2,000x. And my last is the negative x times negative 50x, which is negative 50x squared. So we good with those numbers? Okay. So now what we need to do is, well, I'm going to do a couple things at once. I'm going to simplify this, but I'm also going to reorder these terms so that they are in the standard order of, look at the top of the screen, ax squared plus bx plus c. And I'm going to move this over here because I'm about to complete the square, and I'm going to need a little bit of wiggle room, some cushion room here. So those numbers look okay. What's your first step? Your first step, and you may not like this first step. Some of you might, in other words, decide not to do this first step. What have I not done properly here? Is a clerical error that's a crucial thing. It's x squared, absolutely. Not even a clerical error. It's a mathematical error. It's got to be x squared. You may not want to do this step, but I'm telling you, particularly if you feel a little weak in this area, I would recommend doing it. Move that 140,000 out of the way before you start factoring. Can't tell you how many times I'm marking a student's work and they're factoring out that negative 50, and all of a sudden they're factoring it out of the constant term, which you don't want to do. Now what we're going to do is say that I cannot add a number to make this a perfect square trinomial. Whoops, I don't know what happened there. I cannot add a number to make it a perfect square trinomial, which is part of the process of completing the square, until I have a 1 in front of the x squared. So I need to figure out now, what do I get when I factor negative 50 out of 1,500? And I believe it's negative 31, but I don't know for sure. Just negative 30. Yeah, right. So I get minus 30x. And now I'm all prepped and ready to go for that almost final step of completing the square. I got to put in a number there that makes what's in brackets a perfect square trinomial. So the number that goes here will be what we get when we take half of 30 and square it. By my count, it's 225. But I've tipped the apple cart over. I've upset the apple cart. I've changed things. The equation's no longer valid with that 225 there. It's wrong. But I can pick the apple cart up and correct that mistake. I could correct it by just erasing the 225, but that doesn't get me anywhere. What I need to do, though, instead, is outside of the brackets, make a correction, a numerical correction, where the 140,000 is. And I would like everybody to figure out what I need to do over outside of the brackets. Joel, have you got it?
I'll multiply 225 by -50.
Right. So I have to, before I make a commitment as to what I'm going to do outside of the brackets over here, before I do that, I have to take this -50 and multiply it by the 225, which shows a true value of what I did. I think that's 11,250, isn't it? Negative 11,250. So what I've really done by writing 225 is there's two ways to look at it. I've added negative 11,250. Or another way to look at it is I've taken away 11,250. The bottom line is I have to do the opposite over here. You should start to see how this number is going to turn into what we had for an answer. And you can maybe see how what we have in here is going to turn into part of the answer as well. The fact that it's 50 is not really relevant outside of the brackets. The fact that it's negative 50 is pretty important. The negative tells us this parabola opens upside down, but let's face it, we knew that because it was negative 50x squared. This becomes x, and then we have half of this coefficient, so minus 15. Quantity squared, and then plus 151,250. Which, really, everybody, that's vertex form. Translates to this picture on the right-hand side of the screen, doesn't it? We just figured out that the revenue is equal to negative 50. Then we had x minus 15 quantity squared plus 151,250, I believe. So the vertex is at 15, comma 151,250. And then you could finish the question. I know I've just erased the work for the number of tickets and the number of seats, but you would have to show that work on a written response. Anyway, is that okay, Sasha? Very valuable type of question to know how to do. So when I said some max-min problems, you're given the equation, I'm telling you on a written response, I would not give you the equation. You'd have to come up with it. And that's one example of a type of equation where that would happen. Other questions? There's three topics: the vertex form of a quadratic function, the standard form of a quadratic function, and completing the square. Within that are word problems and those types of things, but we started doing those word problems right with the vertex form of a quadratic function. Except that when we talked earlier about you either having to come up with the equation or the equation's given to you, when we first did word problems, it wasn't even the equation that was given to you. We gave you the graph. And you need to understand that the vertex form of a quadratic function can be written as f of x equals a times x minus p quantity squared plus q. And a, p, and q tell you a number of things about the quadratic function. If a is greater than 0, then the parabola opens up, and if a is less than 0, the parabola opens down. So this is just fundamental things that hopefully you don't even have to study. If a is positive, the parabola opens up. If a is negative, the parabola opens down. This next point, I wouldn't maybe worry too much about. I feel the need to mention it because it's important for Math 30. But whatever the absolute value of a is, and all that means is if it's negative, I don't care about the negative right now. Whatever that number is, it's called a stretch factor. And if that number, the next point says, if that number is bigger than 1, not bigger than 0, bigger than 1, if it's 1.5 or 2 or a million, what happens is the parabola becomes taller and narrower. That's really the skill or the knowledge that we have as an expectation for you at this level. And if a, the absolute value of a rather, is a number between 0 and 1, like 0.5, then that's going to make the graph shorter, and as a result it will appear wider. These are all things that you need to know. Continuing on with the vertex form of a quadratic function, the domain of any quadratic function is always any real number. It always extends from negative infinity to positive infinity. You can't get beyond that. You can't get past that. But the range is not an infinite set of numbers. If the parabola opens up, and I think this is fairly basic, but some of you might need to slow down and think about this on an exam. If the parabola opens up, because a is positive, then there's a lowest point. And I know what happens with some students. They think opens up, a is positive, those are all positive kind of ideas, and then they glom on in their head to the word maximum, because maximum is kind of like a positive thing. But if the parabola opens up, then the parabola looks like this, and there is a minimum. So that means that whatever the minimum value of that is, which will always be the y coordinate of the vertex, the range will be y is greater than or equal to that value. But there will be a minimum. On the other hand, if the parabola opens down, then it would look like this. And there would be a maximum y, and that maximum y is q. So the range would be y is less than or equal to q. And before I finish this off with the vertex form, again, I think this is very simple stuff. And I know that most people will listen to this and go, yeah, that's very simple. But it's so easy on an exam for your brain to slip a gear when you're thinking of some of this stuff. I liken it, especially when I teach my Math 30 class and my calculus class, I liken it to me being just on autopilot. It's like I'm on cruise control and I'm just doing math. Have you ever been reading a book and then you realize that you've read 10 pages and you forgot what you've read? It's kind of like that I do all this work on the board and I go back and I go, man, I don't even remember writing that. Because my brain goes on autopilot. Just be careful about that. Think about these things. The vertex is at p comma q, and the axis of symmetry has an equation of x equals p. Then we learned about the standard form. And I want to point out to you two things about the standard form, which is ax squared plus bx plus c. One of them is a is a. If you're looking at the vertex form and you see a is negative 2, then when you get it into the standard form, a is negative 2. So there is this a, which carries the same amount of information as this a. So if you see a quadratic function that's described by the function f of x or y equals negative 1/2 x squared minus 2x plus 10, then you can tell me that that is a parabola that opens down and is wider than y equals x squared, even though it's not in vertex form. Your description of the function kind of ends there, except for the fact that this is the y-intercept. But in terms of the vertex, you can't tell me where the vertex is. So everything about, well, this function here, everything about this function as an example, except for the y-intercept and whether it opens up or down and is wider or narrower, everything else can only be found on your graphing calculator unless you complete the square. Okay? But what I'm telling you is twofold. Be very careful here and be crafty about this. You're writing an exam and it's a multiple choice question, and I say, what is the maximum value of y? You can either complete the square of that, which means factoring out a negative fraction, which right out of the gate, you're asking for trouble. I mean, it's not beyond us. I would expect you to be able to do it. But if it's a multiple choice question and I say, what is the maximum value of y? My first inclination is to use my graphing calculator. Just because we graduated past this into completing the square doesn't mean it's not a valuable tool. And I think students in high school sometimes forget the level of difficulty that this eliminates in a lot of problems. So if I were to do this, I would go negative 0.5 x squared minus 2x plus 10, get rid of all this other garbage. Always double check your entry here before you graph it. Don't forget, we played around with the zoom settings or the window settings here for that problem. So I would probably go zoom standard. I mean, that's really closing your eyes and throwing a dart at a board. Doesn't really show me much, right? I mean, I suspect that thick line means there's something going up and then maybe down somewhere else. I don't know. But what I could do is I could go to my table set, start at 0, go up by 1, start tracing it. Well, look at that. Y starts at 10. Well, that makes sense. That's the y-intercept. And then look at that. It's already down to negative 20, negative 30 by the time I get to 7. What is it doing in the other direction? Going up, up, oh, and then it's going down. So this, I haven't shown it to you this way before, but I wish I could make my table bigger, like longer. But do you see that the y coordinate of 12 there is kind of, it's the middle of the y values? In other words, if I could turn this into a graph, over at negative 5, the y coordinate is 7.5. At negative 3, it's 11.5. It's climbing. Between negative 5 and 0, it's climbing and going up, and it's peaking around 12. That's pretty good information. That tells me that my window settings could be set from negative 5 to 0 and 0 to 12 if I'm interested in the maximum. Not any X-intercepts or anything. I've never done that before. To how many of you does that make sense when I flip that by 90 degrees? You kind of get my drift? Okay. So it's not a total waste of time. So window setting, negative 5 to 0. Have I talked to you about the scale, what it means? It's how many each tick is. And it went up to 12. So I'm going to go up to 15. I suspect it's 12. And I'm not sure how many of you will really appreciate this. In fact, I'm pretty sure it's 12 because the y value just a bit to the left and to the right are the same number. So, I mean, parabolas are symmetrical. So if it's at 11.5, this far away from the vertex and this far away from the vertex must be at 12. But anyway, you can answer the question. Max, left, okay, right. Let's go negative 1. Good enough. You know, I'm also assuming you know how to use your graphing calculator. So the coordinates of the vertex are negative 2, 12. So should you be able to complete the square? Yeah. Do you have to all the time? No. Going back to my discussion here, I want to clear out this stuff. Well, actually, you know what? Well, we'll go with the same function. It's on my graphing calculator. This point about the X-intercepts is a really important one. You may encounter in some of your review work in your textbook and some other handouts problems where you're finding X-intercepts or asked to find X-intercepts. You don't know how to do it algebraically. The X-intercepts can only be found on your graphing calculator. But I would still expect you to be able to do it. So let's review how to find X-intercepts. I'm going to go back to this graph. Obviously, I can't see the x-intercepts, so I don't have a chance of finding the values of them. I know, just looking at this, that one of the x-intercepts will be over here someplace, one of the x-intercepts will be over here someplace. If this was -5 to 0, I think I did, it would make sense that I would probably want to go, at least -10 to probably 6 or 7, but I'll go 10, -10 to 10. So let me show you what's going to happen now. I go -10 to 10. This is good. I can see the x-intercepts, but I can't find them. I need to have some air under the x-axis for this to work, because I need to be able to put my cursor a little bit below the x-axis. So I would change my window setting for y to -5 to 15. That way I'm going to see this point where it crosses the x-axis, and I'm going to see the other point where it crosses the x-axis, and I can put my cursor in there. Which option do I choose to find the x-intercept? Bless you. Nobody knows? Okay. You choose the 0, number 2. A 0 means where y is 0, which is the definition of an x-intercept. So then it says left boundary. I'm going to put my cursor to the left of this x-intercept. I am to the left of it, which happens to be above. I hit enter. I put my cursor to the right, and I hit enter, and then I hit enter when it says guess. So one of the x-intercepts is about 2.9. I want to point out to you again that when I put it to the left of that x-intercept, I was above. But when I do the same thing for the other x-intercept, to go left of it, I have to be actually below the x-axis this time. So it isn't about above and below, it's about left and right. Yammering away here, trying to get over here. There we go. I'm to the left of it. Hit enter. Hit enter. And there's my other x-intercept. So that's the only way you know of to find x-intercepts. And again, if you want to find the maximum or minimum, you can either complete the square or use your graphing calculator. Speaking of completing the square, well, we've done so many of these. This slide or page or handout that you're looking at right now doesn't tell you how to complete the square. That's in your notes. What I'm saying is you need to know how to complete the square. You need to be able to take a standard form and put it into Vertex Form. But you need to know how to do this not just because there's a written response question that asks you to do it. I could give you the following situation. I could tell you that Peppermint Patty is completing the square of the following function. Sure. And this is Peppermint Patty's work. Okay? Sure, why not? That's Peppermint Patty's work. She's done it perfectly. She has not made a mistake anywhere. She's a good math student. The question is, what are the values of A, B, C, D, and E? Now, I realize if I made this a numerical response question, I would just ask you for A, B, C, and D. Okay, because there's only 4 boxes. But you should be able to fill in those boxes. And I've chosen a particularly simple example because, to be quite honest, there's no fractions. I could do this with fractions as well. Just because fractions are tough doesn't mean we can always avoid them. A would be 2. Because when you factor the negative 2 out of the negative 4, you get 2. B would be 1 because you have to take half of 2, which is 1, and square it, so you would get 1. C would be another 2 because you have to multiply this negative 2 by this 1 to see that you've subtracted 2, so you need to add 2. D would be 1 because it's half of the coefficient of x. And E would be 10 because it's the sum of the 8 and the 2. And that was just off the cuff, but I'm pointing out to you that I can very easily come up with multiple choice or numerical response questions on completing the square. You still have to know how to do it. Make sure you know how to do this. And that's the unit. I mean, in terms of word problems, in terms of max-min, I've created a separate page here for this. Optimization problems, this is covered in all 3 sections. But ultimately, when you want a quantity to be made as big as possible, like profit, or as small as possible, cost, we are said to be optimizing the quantity. The maximum or minimum that you're after in these problems is always the y-coordinate of the vertex. The x-coordinate is the value of some other quantity that results in that. It might be how many lemon trees to plant to maximize the number of lemons. It might be what to charge per ticket to maximize the revenue. It might be the length of a corralled off area to maximize the area. So common problems where you need to develop the quadratic function in order to determine the optimization include the following. So the bottom line here is saying these 2 illustrations are ones where every student is expected to be able to do it without being given the equation. And we've already gone through a revenue problem today. You'll see some more in your practice work. But I thought just to end off this review, I would make up an area problem. Okay? So the area problem is going to be, and you know, it could be any variation of this. This is just one off the top of my head. There's a river, and you have a shepherd, a person who herds sheep. Sheep are not fans of getting into fast-moving rivers, and the shepherd needs to corral the sheep off. But since they're against the edge of a river or the shore of a river, they don't need fencing there. For some reason, I don't know. I'm not a shepherd. I don't understand these things. Maybe they don't want the sheep mating. They need 2 separate corrals. For the males and the females, I'm sure there's names for those things. Ewe? Is ewe a female? Ram? Doesn't matter. I'm probably just demonstrating my animal ignorance at this point in time. Anyway, for a number of reasons, they actually want 3 sections. And they have, I don't know, let's say 1,000 feet of fencing. And the question is, what's the maximum area? What are the dimensions that will produce the maximum area? Much like the revenue problem, you would be given this maybe on a written response where you're asked to determine the equation first. I wouldn't just say find the maximum. I would say determine the equation. I might say something like, if you call this x, what's a formula for area in this form? Remember when we did the revenue problem, we had to multiply it out? We had to FOIL it out? That's what I'm talking about. It needs to be in this form. So that would be the first question. Well, you need to define the area, first of all, by saying area is length times width. And then what we could do is say, well, the width is x, isn't it? This is x, that's the width. The length is this distance. So all I've done is I've said I'm not going to use w, I'm going to use x. Okay. And here's where this type of optimization problem is different than the revenue one. In the revenue one, we only had x. We had revenue and x. In this one, we have area, we have x, but we also have L. So as I was saying actually in my Math 31 class a little bit earlier this afternoon, this needs to go. You cannot imagine having a graph where area is here and you want to maximize area unless you have only one other variable. You can't have another variable. We don't know what a graph of A equals L times X looks like when L and X are both changing. You can't wrap your head around that. So that's why that needs to go. So who can, well, give it some thought here. How would we go about getting rid of the L? This is a totally different thing than the revenue. We're still going to complete the square. Joel, do you know?
You could take the x out of it by subtracting.
Can you be more specific?
So what I would have would be L times x equals area.
Yeah.
So you could subtract x from the L side and subtract x from the A side.
So first of all, to get rid of the x, you would have to divide. But it turns out that if you did play around with this equation to get L, let me show you what would happen. It's an interesting thing. And it will be interesting because if you ever find yourself in this position, you will now recognize it, that you're using the wrong equation. What some people will say is, if I want to get rid of L, let me rearrange this for L and then put this in for L. That's kind of, I think, what you're thinking. But what happens if I put that in for L? And you're not writing this down because it won't work. What happens is you're going to get your A equals L, which is A over X times X, and the X's cancel, and you've come up with, although true, not a very helpful statement in this problem. You've figured out that area equals area. So I'm glad you said this, because even though it won't work, there's a lesson to be learned here. And it's that whenever you want to eliminate a variable, which happens a lot in high school math, you can never eliminate a variable from an equation using that equation to eliminate it. It just won't work. You'll end up with 5 equals 5 or something. So I'm giving you guys a hint now. There must be some other equation that we can rearrange for L. But I haven't written the equation down as an equation. The information is all here. Any other ideas? Jack?
You need to rewrite it in vertex form.
But I can't rewrite this A equals LX in vertex form because I don't even have it in standard form yet. I got to get rid of that L. Lucas? A equals 1L times 4x. Yes. I understand what you're saying, but and I'm really glad I decided to throw this one up. This is not the area. It doesn't matter how many of those sections I have, the area will be the length times the width. I mean, we could say it's 1/4 L times X plus 1/4 L times X, etc. But we're still going to get Lx. So it turns out this is not true for the area. The area will always be, and again, I'm glad we're talking about this, the area will always be the length times the width. And the length of this big rectangle is L and the width is X. Yeah.
Is it 1,000 equals 40x plus?
Right. You have to use, perfect. You have to use the amount of fencing here to find a different relationship between L and W or L and X. So it's exactly right. It's 1,000 is equal to 4x plus L. Now, by the way, if I didn't say use X, then you would have had 4W plus L. I hope it's reasonable in your head that you would want to get rid of the L anyway, because it's easier to rearrange this little beast for L. Right? It's 1,000 minus 4W. So L equals 1,000 minus 4W. L needs to go because you can't think of a parabola unless it's area which you want to maximize as a function of one variable. You can't have area as a function of two variables. It doesn't work that way. Graphs have two variables in total. Area is one of them. So what we are going to do is put this here. I'm of the opinion that the math here, the algebra in the area problem is simpler than the algebra in the revenue problem. Because in the revenue problem, the numbers get quite big, which makes the algebra a little more cloudy. But I do understand that this is more complicated to think about. But look at what happens when we do that substitution. Now we're going to have area equals L, which is that thing up there, 1,000 minus 4W, times, 1,000 minus 4x. Do you see what I've done there? I've toggled up here. It was x and I changed it to w. It's x. Hey, I don't care if you want to use w, use w. But this is x. So times x if I expand this, I'm going to get negative 4x squared plus 1,000x. I've multiplied that x through, and then I've just rewritten the two terms in a different order. I'll put the x squared first. I know from experience that if I gave students a choice of doing a revenue problem and an area problem, more students will do the revenue problem. I don't know why that is. But we're so close to being done here. We don't have to figure out ticket price, number of tickets. We just want to figure out the area and the dimensions. Complete the square. Take out the negative 4. Maybe what confuses some people here is there's no number here, right? Put a number there. Put plus 0. Bump it way out of the way so it doesn't get in the way of your algebra. Take the negative 4 out. How did my division go there? Is 1,000 divided by negative 4, negative 250? Okay. I need to figure out what to add. I need to figure out what to add in here, so I have to take half of negative 250 and square it. So 15,625. Good. So I need to add 15,625. What do I do outside the brackets? Well, before I commit to that, I better see what I actually did by putting 15,625 inside of the brackets. And what I really did was I subtracted, so 6,500? 65,000? I'll just randomly shout out numbers until I don't know. $62,500. Negative 62,500. So that means I add 62,500. The more astute, quicker student will recognize that that is going to be the maximum area before we're even done, because it's going to be the y coordinate of the vertex. But to finish this problem off, a is equal to negative 4 times x minus 125 squared plus 62,500. What this means is that since we have a negative 4, the parabola opens down. The vertex will be at 125 for x, comma, 62,500 for area. So, what is the maximum area? 62,500 square feet. I believe it was 1,000 feet, wasn't it? Yeah, 62,500 square feet. What are the dimensions that would give it? Well, we decided that x was 125. Lots of ways for you to find the other dimension of length, but I would just caution you that we're back in this territory now. Maybe it was my period 4 class I was talking to about this. Some things can be so simple that you think they don't require an explanation. If it's a calculation that's involved, I don't care if you're subtracting an amount of money minus another amount of money. You have to show it on a written response. You have to show that work. So, when I stand up here and say how I would do it is I would add those up and see that I get 500 feet, which leaves 500 feet for the length. You'd have to write that down. The most efficient way to do it is to use this formula, right? X is 125, so 1,000 minus 4 times 125. But you have to show it. How many of you would take 62,500 divided by 125? You might do that because area equals length times width. So I will finish with this parting thought. I'm telling you that the written response section, something that we feel in this high school is important for Math 20 in this unit, will involve completing the square. We also feel it's important that you can solve word problems and show all of the work. We also feel it's important that you know how to do revenue problems and area problems. And I've told you that on the written response you will have a choice of 2 problems, one to choose from out of the 2. Put all that together and I'm giving you a lot of valuable information about your exam.